Oh. All right. So we are live with our Kubernetes exploit and post-exploit tour. First of all, thanks everyone for joining us. There's been a lot of attention on this, and in fact, a lot of people have been writing to us before this to talk about this. So I'm really happy to see that we've been able to do this one more time, and of course, we're continuing this over time as well. So today, just a quick introduction. My name is Abhay. I run V45, do a lot of technology stuff at V45. I train at various events like Black Hat, OWASP, DEF CON. I've done a lot of work in the open source community as well. With me is my colleague and friend, Sharath. Say hi, Sharath.
Hi, all.
So, Sharath, you want to introduce yourself?
Yeah, sure. I'm Sharath. I'm a lead solutions engineer from V45, where I'll be doing a lot of training and also developing a product called Orchestron, which is a vulnerability correlation on an orchestrated platform. And on top of it, I also do a lot of meetups, and I attend meetups. I give talks on meetups, and also do some kind of live coding sessions like this. And I've also built certain labs and certain courses, and I've also helped V45 throughout my career, building the labs and building the products. So that's about me. And over to you.
Thanks, Sharath. Thanks, Sharath. You've been very modest with your introduction. I think you've done quite a bit more than that. So Sharath has been responsible for most of the labs we're going to look at today. In case you're wondering where you can get access to these awesome labs and content, of course, we're running a lot of remote trainings. I'm sure all of you are sitting at home. You want to learn something new, something interesting, and still get access to awesome labs. Look at v45.com/remote training. That's v45.com/remote training. And then select whichever training you want. We have a cool discount code as well, as you can see on screen. So I'm just going to put up that link on screen for all of you to get started. And we are, like I said, we are doing a lot of stuff in the community. This is our YouTube channel. Please follow us on YouTube. We do a lot of blogs, and of course, all of us speak at a lot of events. So with that, let's get started with our session today. So the first thing we're going to do today is we're going to look at, first of all, we're going to deploy a Kubernetes cluster, and we're going to deploy a simple Kubernetes cluster on our lab environment. So we're going to be doing this with our lab environment. We have a Kubernetes focused class. And as part of our Kubernetes focused class, we teach you how to attack and defend. So which means that you learn how to break stuff and secure stuff with Kubernetes. It's not only that you learn how to break things or learn only how to secure things. You get both perspectives. So this is where we excel, and we have a lot of stuff around this. Today, we're going to specifically be looking at a Kubernetes exploit lab as part of our lab environment. So let's get started without further ado. So today, this is just a one lab thing that we're going to be doing, but this lab is quite intense, as you will see. So let's get started with this. And I'm going to start up our lab. The cool thing is, like I said, I'm not sure if you've seen this, but our labs are accessible completely on the browser, right? So you don't need any additional install. You don't need any virtual machines. You don't need anything like that. So our labs are accessible completely on the browser. So you just, as soon as you click on the provision lab button, just like I did, you get access to the lab. The lab is being provisioned. A dedicated lab environment for you is being provisioned in the back. In the meantime, let's quickly look at some theory to talk a little bit about Kubernetes. Now, if anyone has any comments, please leave them in the comments. But let's get started with a little bit of Kubernetes theory, just to give people who are not so familiar with Kubernetes an understanding of what Kubernetes is. Now, Kubernetes, as many of you might have heard, the term itself is of course, Kubernetes has been around for a while, but today, more than ever, Kubernetes has become extremely popular. The reason why it's become popular is because it gives you the ability to run containerized applications and workloads in an extremely orchestrated environment, extremely orchestrated way. It gives you scalability, it gives you replication, it gives you a ton of features that you can run production-heavy workloads on it, and you can actually scale them up. So let's say you want to add 10,000 replicas of your app server. in a blink of an eye, you can do that with Kubernetes because it gives you the tooling and the API and the capability to allow for this sort of thing. Now, the Kubernetes architecture, this is a very high-level perspective of the architecture itself. So Kubernetes, typically, it's all API-driven. Anything in Kubernetes is an API. You can build your own resources and definitions for it, but you typically have to talk to Kubernetes through its API, right? So some of you who work with Kubernetes probably know about kubectl or kube controller or whatever you might want to call it. It's essentially kubectl. That is the command, that is the CLI that we denote in this image here. You might also be working with the UI of some sort. Now, the UI may be something like a simple web UI or web client that we have, but you also have like a ton of other UIs from different companies. I think you have one. I saw a very cool one from VMware called Octant. That's a really cool. I liked that approach to handling Kubernetes UI, but there are lots of others. It's not the only one by far. In fact, yesterday I saw someone who written a Kubernetes controller in Excel. Can you believe that, Sharath? Excel.
So Excel is kubectl, I guess.
Yeah. That was wild because I mean those are two extremely disparate things, and suddenly this chap writes something. Or yeah. I don't know whether it's a chap even.
One way it's towards the modernized, one way it's the legacy. Mix of both.
Yeah, exactly. So that's Excel, right? So Kubernetes essentially has your API server, the scheduler, and the controller. These essentially control the deployments. They manage how the deployments work. They manage where the deployments go, where your resources are deployed. You also have an HCD in that particular Kubernetes master deployment. This essentially counts as a control plane, right? And the HCD is your database. So Kubernetes uses HCD, which is a key value store, as a database for handling all of the current specifications and current specs that it's running and configurations that it's running. So if you run a new application, so let's say I deploy a Redis database, or let's say I deploy a Java application on my Kubernetes cluster, the state and information related to that Java application is going to be maintained in that particular HCD database. And a lot of times, if earlier on, at least, not so much anymore, but previously when we used to see on a lot of pen tests that HCD would be compromised because it was running without too much protection and stuff like that. Then, of course, you have the nodes where you're actually running all these workloads, right? So all of the nodes, the node 1, 2, 3, 4, is where, of course, you might have many more nodes, but we've just denoted it with 4. You might be running all of this on all the workloads on these nodes. And these nodes, you have pods and deployments and services that you are deploying on these particular nodes. Now, I'm not going to go extremely deep into Kubernetes because that's an ocean unto itself. But just to give you an understanding, this is the high-level way that Kubernetes works. Of course, you use containers. Kubernetes is all about containers. It helps you run, scale, and manage containerized apps. And that's what we are going to do today. So hopefully our lab is started up. You'll see that our lab, okay, it's already started up, and I've been talking a little bit too much for a while now. So our lab is started up, and I'm just going to quickly get in full screen mode. So our lab, as you can see, gives you like a pretty cool IDE environment. Sharath, can you see the screen? Is it?
Yeah.
Cool, perfect.
I think it's easy to handle in mobile or iPad devices also, I guess. Using this.
Yeah, iPad. Yeah, absolutely. That's a good point. So iPad, you can just do this on an iPad. Mobile, not so much. But iPad definitely is a pretty awesome experience with this. We've had students taking a lot of training on their iPad. So let's get started. Now, in this lab environment, we have all the necessary stuff to run our Kubernetes deployment. So I don't know how many of you attended our fantastic vulnerability session, but you might have seen that we demoed a vulnerability called server-side template injection. Now, server-side template injection, Sharath, you want to explain a little bit of server-side template injection?
Sure. Adding to what Abhay asked was, last time in the previous fantastic vulnerability session, Abhay has talked about a pug-related template vulnerability, I guess. So here, in the template injection, there are two types of template injection. One is the client-side template injection, other one is the server-side template injection. Client-side template injection usually happens with this AngularJS, React.js, and the Vue.js kind of frameworks. But server-side template injection happens by the programming language like Python, Java, or PHP as such. And for every programming language, there are a certain set of template languages. For PHP, there's something called Mako. For Python, there's something called Jinja. For Java, there's something called FreeMarker and Velocity, and there are a bunch of like that. So in that, using the template, you can actually render the dynamic content on the HTML screen where the user can see the live contents. For example, if you see your profile, you can see the first name and the last name. All that are rendered through a templating. So what the attackers do with that templating is that they try to inject a malicious code into the template and try and achieve something really, really scary or get access to your system and do something malicious activity like that. So how an injection works is instead of entering a genuine value, they try to enter the code or they try to access some illegal files and then do malicious activity there. That's how a server-side template injection works.
Yeah. So basically, Sharath. Basically, what the idea of a server-side template injection is that it gets into remote code execution territory. So in this attack, what we're going to do is we're first going to see if our application is vulnerable to template injection. We're going to exploit that template injection with a tool called TPL map. Now, I don't know how many of you have heard of TPL map, but I demoed TPL map on our fantastic vulnerabilities session. In fact, I'm just going to post some links here, right here on TPL map. This is the one. So this is a pretty cool tool that we're going to be using to showcase the template injection and also exploit the template injection. So once we exploit the template injection, the idea here is that we get remote code execution, right? Once we get remote code execution, we want to escalate privileges and gain access to the entire cluster. So not just in this case, we'll see that not only is that possible, but we can also do a lot of dangerous stuff. Like in this case, we want to steal credit card numbers. So that's what we're going to be doing. We're going to be stealing credit card numbers and going shopping, right? So let's get started. I'm going to just quickly CD into that directory. Now, I'm going to be using kubeadm to set up a small cluster. Sharath, you want to just quickly talk about kubeadm?
So kubeadm is a server-side component where it will create a cluster on that particular box, and it will join the cluster to that particular machine. And it will set the kubelet in that particular environment where you can run the parts and the services on that machine.
So basically, kubeadm gives you like a very small single node, or it helps you give single node, deliver single node clusters, especially when you want to do testing or you want to run your applications and figure out stuff. That's when you would typically use something like kubeadm. So we've already installed kubeadm, but we are just going to initialize it like so. And once we install kubeadm and all the dependencies for Kubernetes, we're also going to install a network. Now we're going to be using the Calico CNI or networking interface for Kubernetes that gives you a network in Kubernetes. So that's basically what we're doing at this point in time. And then, of course, we're starting up our kube node. So the setup kube.sh script gives you access to that. We're going to run setup kube.sh real soon. Setup kube.sh, and you will see that it is going to start setting up the Kubernetes cluster. So if you thought setting up a Kubernetes cluster is extremely hard, I'm sure you'll see that it's not that complicated. In fact, with kubeadm, anyone, or a lot of other ones, there's K3s, Minikube, there is, of course, kubeadm. I'm sorry?
Kind.
Oh, Kind, yeah, we have Kind. You have so many ways in which you can quickly get a Kubernetes cluster running even on your own machine. So it's pretty cool that you can play with stuff like this and run it on your own machine as well. kubeadm is what we use because we like to be able to control some aspects of it, especially for our labs. But hey, it really depends upon what you're doing. So you can see that it started, or it's downloading all the containers that are necessary. It's downloading etcd, it's downloading the proxy, it's downloading the API server, it's downloading it's also generating the root CS. So a lot of Kubernetes is essentially certificate-based authentication, which is why it needs a certificate authority, it needs a certificate and key. So it generates that. Of course, you can use third-party certificate authorities, or you can use a third-party CA as well if you want. So all of these things are generated. So you'll see that our network has also been created with Calico, and all that stuff is done. So if we go back to, if you use kubectl, which is the most popular, which allows you to control Kubernetes, kubectl get nodes, you will see that it's running. Our current node is running ready for actually deploying stuff. The next thing we're going to do is deploy our application, which is our vulnerable application. Now, when we are deploying this, we need to do a few things. We are also doing a few things other than just deploying this. So first of all, we are creating a service account called depadmin. And in the service account, this service account is being bound to a cluster role. Now, if you do role-based access control, a role is essentially bound to a group or a user, right? So in this case, we're binding the role to a particular user. Yeah. So in this case, of course, when we decide it's cluster role, it's bound to the entire cluster, right? It doesn't mean so Kubernetes. You can also bind a role to a namespace. You can create a role and a role binding, or you can create a cluster role and a cluster role binding. So as much as possible, when you do stuff, you should restrict it to a namespace so that the blast radius of whatever happens within that namespace and does not go all over the place. This is not a good practice, ideally. You should not be directly assigning a lot of cluster roles and privileges. So we are defining a cluster role that says, hey, give me star access to anything. So if you are from the AWS...
I think Helm also creates a cluster role, I guess, correct?
It used to. Helm 2 used to create a service account. That's a good point. Thanks for that. Helm created a full, Helm had a product called Tiller, and Tiller created a cluster role binding and gave it pretty much service account on. It gave itself a lot of privileges on the Kubernetes cluster, but that was Helm 2. Helm 3, they've realized that was a huge way of shooting yourself in the foot, and they have, I think they're not doing that anymore. Okay. So I don't have the technical details off the top of my head. I'm sorry, what?
People who are already using Helm 2 should move to Helm 3 then.
Yes, most definitely. But yeah, make sure that you move after validating whether Helm 3, because some folks told me that Helm 3 has a little bit of compatibility stuff with it. Anyway, so we are creating a cluster role binding, which gives me complete access. The service account gives complete access to everything on Kubernetes, which you can automatically realize is not a good thing, right? It's not great. It's like an IAM privilege on AWS that has access to star on every resource, everything. So this is a bad deal. The next thing we're doing is deploying our app, which is as a service. So this exposes the network aspect of the app to us outside. So we are allowed to interact with the service. If we don't declare a service, we can't interact. And then, of course, we're creating some secrets. Now, all of these are base 64 encoded. They are not encrypted. Now, remember, Kubernetes has something called a secret, but the secret is not encrypted. Right? You need to do encryption your own way. It just gives you an object to store your secret, but that doesn't mean it's encrypted. So please make sure you remember that's a huge. In fact, when I started learning Kubernetes, I was like, what? This doesn't do encryption? That's so weird. Makes no sense. But anyway, that's the way it is. You have to figure out. So use something like Vault or Sealed Secrets or whatever it is to do secrets, right? And then, of course, we're going to deploy our app. Our app uses a Flask Python application and a MySQL database. And you can see that MySQL has a bunch of references to the host, the root password. Of course, running it with root password privileges itself is a massive warning sign. So let's deploy this. We have talked about it too much. Let's go about it and actually deploy this on our cluster. So when I do kubectl apply-f, it's going to create all of those things. And I'm going to check whether it is deploying stuff. kubectl get pods -w gives me real-time info of whether that those pods and those applications are being created and generated, right? So you can see that some of it is still being created, some of it is running. There is a couple of errors, but I think you'll see that they kind of smooth over time, and you'll see that it actually works. So we're deploying this as a deployment object, and it should be done pretty quickly. Now, in fact, you can get the entire state of the deployment with a command like this, right? So if you do this, you get the whole thing. In fact, all of this seems to have been deployed. It's running up to date and available. Now, we have exposed this on a very weird port and not the standard port. So I'm going to just open up another browser window and access that port. Just give me a second when I do this. I'm going to copy this value and I'm going to just open up a browser, go to port 32345. 32345 and go to the payment. So imagine that I'm loading a credit card on here. So let's create a credit card. So 5111 right? So this is my credit card number, 16 digits. You can verify if you want. If anyone wants to give their credit card numbers, please type it into the YouTube link. We are very happy with such contributions. But in any case, so let's select an expiration date. Let's just select whatever, April 2024, right? And we'll select a CVV, which is 123, and we're going to submit it. So this creates that credit card in our system. Now we are hoping, obviously, and I think in this system, the credit card number is encrypted. So as an attacker, not only is our interest to compromise the credit card number, but to not only to get access to the credit card number, but also decrypt it maybe as part of it. So let's say we're a financially motivated attacker. Now, the way we do it is by exploiting template injection, right? So let us say I have a 404 URL, right? So let's say I have a URL which goes by this, right? So let's say the page does something, and it's going to give me this echo. Whatever I'm looking for in a page, it's going to just echo this here. Now, when I try and do something interesting with this, like 4 into 4, and see whether it actually echoes something interesting, you'll see that it actually multiplies this and gives you the result 16, which is interesting because 4 into 4 is, of course, 16. But the fact that you can do this, it's actually being interpreted by the Python interpreter in the back, and you should be able to actually do something a lot more interesting with this, right? So now if I
want to add a point here. So I think Uber also had something similar like this, where a guy typed 7 string into 7, where Uber sent a letter saying that Mr. 7 times 7, you have completed a trip with us, thank you, something like that, correct?
Yeah, exactly. Uber had this very flaw. That's a good point. Uber had the same flaw with the same system. This was in 2016, I think, end of 2016. So they had this flaw. Yeah, there was a pretty bad flaw. So now if I do something like config.items, maybe I can pull some information from the backend application, right? So if I do this, you'll see that it actually is able to pull up all kinds of interesting stuff from the backend. Now I want to do more stuff. In fact, you'll see that a lot of information has been given right here. Now I want to be able to use this and actually start infiltrating the database and gaining access to a lot of sensitive info to the database and maybe even the operating system, right? Now, I have found that this works and I've been able to exploit it, but I want to go faster and I want to use some automation in actually exploiting this. So let's get to that, right? So I want to use TPL map, and I already shared the link to TPL map. Now, TPL map is a pretty cool tool that allows you to exploit. And it's like SQL map. I don't know how many of you have used SQL map, but if you use SQL map, you'll know that you can exploit SQL injections really gangbusters. You can do some amazing stuff. So what I'm doing is I'm running TPL map on this URL. Now, since I'm running it inside the cluster in the same system, it's going to be localhost. But if I was running it outside, I could do this with that IP address, whatever that may be, or that domain, whatever that may be. So I can do this and say user.html. Now, OS command, I want to dump all the environment variables, right? Print env. When I do this, you can see that TPL map runs the OS command and dumps all of the nice little variables here. In fact, you'll see that it gives a lot of information about the Kubernetes deployment itself. But more than that, it gives a lot of cool information about the database. It gives me something called enkey, which is interesting. It looks like an encryption key. Maybe it is an encryption key. It gives me the MySQL root password. A lot of folks store passwords and API tokens and keys in environment variables. This is why you should not ideally be doing that, because it's especially when your application is vulnerable, it's almost trivially simple for somebody to come and completely compromise this and exploit this head to toe. So do not ideally do this. So you can see that MySQL root password, we found a bunch of stuff. Now let's get the stuff that we need from MySQL, right? So MySQL, let's only pick up the environment variables that are MySQL focused. So what I'm doing is I'm grepping anything with the term MySQL in it. And you'll see that it gave me all of these, all of these variables. So it gave me the password, it gave me the IP address, it gave me the port, It gave me the database. It also gave me the database that I'm using. So I'm using a database called CardDB, right? Now I want to actually, so the way I want to exploit this is by dropping some kind of, installing some dependencies in that. So remember, I'm sitting outside. I'm not in that system, but I'm able to, of course, since I have a remote code execution, I want to be able to expand my reach into that system and install stuff and maybe run my own payload and stuff like that. So the first thing I'm going to do is I want to learn what kind of a Linux box is it, right? So for that, I do etc cat /etc/release, I think.
OS release, I guess.
/OS release?
OS-release.
OS-release. Okay, thanks for that. So when I do this, you'll see that, it's Alpine Linux. A lot of containers are, got built with Alpine Linux, and it's very common. So Alpine Linux, which means I can't use apt or I can't use yum. I need to use Alpine Linux, which is apk update, apk add, and so on. So let's install a MySQL client to start interacting with that MySQL server. And you can see this command. We are installing apk update and installing a MySQL client. So remember, we are actually adding a MySQL install on that container, on that running container that is our application, and then we're going to start pulling out some sensitive data from there. So you'll see that it installed MySQL. It's done with installing it. Now let's run some. So we're actually effectively converting this into SQL injection, as you can see, right? So we're actually effectively converting this into SQL injection. And we're doing, hey, you know what, since we already have the MySQL password, we're also doing, hey, show tables from CardDB. We know that the database is CardDB. So if we do this, you'll see that it says cards is one of the database in CardDB. Now what we're going to do is pull out the data from the cards database, and we're going to do a select star from carddb.cards, and you will see that it dumps some value, and it's dumped what looks like some encrypted data set from the card database, right? So this is a good thing, but we still don't have what we want, right? We still need, you remember when we dumped the environment variables, we had an env key and a salt value there. Now maybe that's an encryption key, and maybe that's a salt for that encryption key, right? So that's pretty cool. So let's pull that and analyze that, right? So let's dump the environment variables again. Let's do print env, and we have a lot of these. Now let's take the env key value. Let's copy the env key value here. Let's say export env_key as this. And let's export the salt as well. Export salt. Now, if you're using anything other than AES ECB mode or any ECB mode cipher, you're probably going to be using a salt value. Again, that's not ideal that you're using a static salt. This is not a great practice at all. It's not. You should be salt per data set and not a single salt. This is a horrible idea, but nevertheless, the application is otherwise also quite horrible. So, so what we're going to do is, now that we have the encryption key and the salt, we are going to actually decrypt this card number, right? So I am going to decrypt. Do I need to copy the card number, Sharath?
If you have the encryptor Python file with you, then I think you need to copy those things to decrypt the card, because that is the card you're trying to decrypt, right?
Yeah. So let me just run that again in that case. Yeah, I'm going to get that card number. Yeah. So this card number I need to copy, right?
Yes.
Okay. So I'm going to just, yeah, 1 second. Oh, okay. You're going to, yeah, the card number.
Yeah.
Yeah. So let's go into, so Sharath has written up a nifty little decryption program. So this actually does a, it's going to decrypt.
It's inside the template injection folder.
Inside that. Oh, okay.
Yeah. kubectl, yeah.
Oh, it's here. Okay. It's decryptor.py. So if we want to look at decryptor.py, you will see that it's going to use the salt. It uses the encryption key and whatever we give it as the card number, and it's going to try and decrypt and come back with the value, right? So let's decrypt it, Python decryptor.py, and we're going to copy this value and we'll paste it, and you'll see that it comes back with our card number. So imagine that this could be scaled up, right? And this actually happened. In fact, there was a time where a lot of bank fraud used to happen with prepaid card numbers, and an attacker use, of course, not Kubernetes. The attacker used JBoss, flaw with JBoss to be able to do something very similar to this. So it's kind of a very it's very realistic from that perspective, where somebody has been able to use this and then use that to walk through and gain access to a lot of this.
I'm sad that nobody gave the real card number.
Yeah, nobody was silly enough to entrust us with their card information, clearly. Now, this is not all you can do, right? Now, with Kubernetes, remember, you can actually, since we have remote code execution, you can actually start then expanding your privileges to the Kubernetes cluster itself. Now, Kubernetes clusters typically have the secrets and the token file in a var run directory. So if I want to get the Kubernetes token file, all I have to do is do something like this, right? So I think I need to go into a different folder. So hold on. So I'm going to, now I'm going to copy this. So what we're doing is we are running an OS command with tpl map and saying, hey, cat, dump this file on my screen, right? Var secrets kubernetes.io. Now, this is a real deadly attack, because remember, we have given the user that has deployed this app is a service account user who has cluster admin privileges to do entire cluster, to administer the cluster, do anything on the cluster. So if I can get this person's or this user's token, you can see that I can pretty much gain access to the entire Kubernetes cluster. So it's like stealing the domain administrator's Windows token in Windows, right? So you can gain access to the entire domain. In this case, you can gain access to the entire cluster. So this, as you can see, is a JWT. And with this JWT, I can pretty much completely compromise this. So what I'm going to do is I'm going to get a shell on the box. I'm going to copy this cluster. So let me just get a shell on that machine. And you can see that I can get a shell on that Alpine Linux machine. So I can actually get a reverse TCP shell back. And I'm going to delete the whole thing. So I can, from this point onwards, I can pretty much do, is there a kubectl on this? I don't think there's no kubectl.
No, I don't think so.
Yeah, so really at this point, I'm just going to kind of go back to that. Oh, no, sorry about that. A mistake. Yeah, so the token essentially gives me access to do pretty much anything I want on the cluster from this point. So not only have we been able to exploit the entire cluster, exploit the database, but we have also been able to gain a complete foothold into the cluster, from which point we can do whatever we want. So you can see that this is a issued from that Kubernetes cluster. It's an RS-256 token. It has a KID called this. And you can see that this is a depadmin token. So this has been given to depadmin. And if you remember from our specification, depadmin is a very, very bad setting. So the depadmin pretty much has access to doing everything on that cluster. So this is a pretty horrible flaw, and this can be exploited quite easily. In fact, I think early days of Kubernetes, I think Tesla had a similar exploit where their Kubernetes cluster was used to do a lot of cryptojacking. And this is a very common thing. We find this a lot with a lot of configured Kubernetes clusters. So if you're a pen tester, if you're a bug bounty hunter, definitely look for stuff like this. If you're not, if you're on the defending side, definitely audit the rules and the roles and the privileges to your RBAC that you have. If you are a large Kubernetes cluster, so let's talk a little bit of defense before we close today's session. So Sharath, some ideas of defense. What should somebody be doing for this?
First thing I would say was hardening the code of the image. First, they should have fixed the temperature injection first thing. And second thing was maybe the service account should have not given more rows like this ****, because it pretty much exposes everything. And I believe the port is also open, I guess, because if this is there, then I believe the port is also open. So the port
MySQL, probably, yes. It is a service, so it's exposed,
So then I don't see any pod security policy kind of a thing implemented here. So
absolutely. So pod security policy is something that, in fact, we in our trainings we use pod security policy to demonstrate how you can defeat attacks like this. Of course, not perfect, but it definitely gets you a lot of runtime protections, even against an insecure application. So it's definitely worthwhile to look at part security policy as a something that you should be looking at very seriously.
Yeah.
Anything
And
else?
one more thing, is the Docker built as a multi-stage so that they could avoid the shell? Is that a multi-stage Docker build or something like that?
Yeah, multi-stage Docker builds would not only ensure that your containers are lighter, they're also more secure because they don't have too many dependencies. And 3, they also you can remove all the unnecessary code like shell, perhaps. That's something that you can do as well. Yeah, definitely. And of course, I think we forgot one thing, which was secrets management tool. Do not store your secrets
everything is basically for anybody to record.
Yeah, so when you're using Kubernetes, definitely look at something like Vault or something like that for your secrets, but do not be storing it in environment variables. Of course, it doesn't mean that your secrets can't be exfiltrated with this kind of a flaw. You can still do it, but with secrets management, it comes with a lot of other features, like, for instance, auditability. You get some access control. With environment variables, once somebody is compromised your app, it's gone. It's over, right? It's game over right then and there. So that's something that you should definitely keep in mind. Right. So, with that, I think we come to the end of our stream. We usually do 30 minutes of this, but I think we kind of extended a little bit more. If there are any questions for people who are on the stream right now, please ask them and we can take some of your questions. Otherwise, please write to us. You can, of course, always follow us at V45 on Twitter. Both Sharath and I have handles on Twitter as well. So my handle is at Abhay Bhargav, and of course Sharath is, what is your handle, Sharath?
Sharath K. Ramadas.
Yeah, Sharath K. Ramadas or Ramdas?
Ramadas.
Yeah, cool. So we got Sharath's handle as well, so you can follow either of us in what we're doing. So it's pretty interesting stuff that we are getting up to. We are going to be announcing a lot more stuff on our training and remote training and live training stuff. Of course, like I said, if you want any live training, you should look at signing up to one of our classes. We're running the special offer only up to May 6th, I think. So definitely look at that. I'm just going to quickly load that slide again. So this is the one. Go to this slide, go to this URL and select whichever trainings you want. You not only get access to the training, but you also get access to certification. You get access to, even after the class, you get access to labs and videos and so on. So you should definitely check this out. And of course, follow us on YouTube. Check out what we're doing here as well. With that, we come to the end. Any parting statements, Sharath, before we close?
There's only one thing I would like to say. Whenever you're trying to deploy into your cloud, you're not charged by your data, you're charged by your computer. So make sure that whenever you're trying to deploy a Kubernetes cluster kind of a thing, where you set up a lot of notification and monitoring, so that you'll not have any cryptojacking kind of an attack where they consume a lot of compute. So you don't necessarily get billed there. You have a lot of bills coming for you there. I suggest you take your Kubernetes thing very seriously. As always, stay home, stay safe, and also keep your Kubernetes safe.
Yeah, of course. Yeah, all of you, please stay safe and socially distance and all that stuff. Thanks so much, and we'll see you next week with something else, something more interesting, something more engaging on many other different topics that we have. Thank you very much. Thanks for tuning in. Bye.
Bye-bye.